All right, so we've got another example here on curve sketching using derivatives. So we've got f of x equals 3x to the fifth minus 5x cubed. Now, to graph this thing, we've got to find the critical numbers. We've got to find where the function is increasing and decreasing. We've got to find any relative or local maximum minimum values. We've got to find the concavity, the intervals where the function is concave up and concave down, and then any inflection points. All right, so first thing, let's go ahead and find where the function's increasing and decreasing. So to do that, we need to find the critical numbers. So to do that, you've got to take the first derivative. So that's 15x to the fourth minus 15x squared. And then you set the first derivative equal to 0 and solve. So we'll factor out a 15x squared, and then that's times x squared minus 1 equals 0. So we get x equals 0 or x equal plus or minus 1. All right. So once you find your critical numbers, you take the critical numbers and you plot them on a number line. So we've got -1, 0, 1. All right. And we've got 3 critical numbers, so that's going to break the number line up into 4 regions. And then what I need to do is I need to choose a number from each region. All right. Makes no difference what numbers you choose, just as long as you choose a number from each region. All right. Now, we have to take the first derivative. Let me erase that x there. We've got to take the first derivative and evaluate the first derivative at each one of these x values. Okay? So you can take each x value, plug it in, and get your y value. Okay? But we don't care. We don't care about the exact y value that we're going to get. Okay? That makes no difference to us. All we care about when we plug each of these in, all we care about is it positive or negative. That's it. Okay? Now, what I want you to understand that this function here is the same as this function. This one's just factored. Okay? I mean, it's not factored completely, but it's factored out of 15x squared. All right, so I'm going to plug the -2 in. All right, so I can plug the -2 in, get a y value, but I don't really care about that. Look, if I plug the -2 in here, that's -2 squared is 4. 4 times 15, positive number. Okay, 4 times 15, this is a positive. And then if I plug the -2 in here, that's 4 minus 1. Well, 4 minus 1 is positive. So this is a positive number here. This is a positive number here. So a positive times a positive is positive. So that's greater than 0. So what that tells me, since I took a number from this region, plugged it into the first derivative, I got a positive number. So that means the function's increasing on this interval. Okay. Now let's take the -1/2 and plug it in. So I get -1/2 squared. Well, that's positive. So a positive times a positive, that's going to be positive out here. And then if I take -1/2 squared, that's 1/4. 1/4 minus 1 is negative. So this is a negative times a positive, which is negative. Let me go ahead and write that down. That's negative. And then I've got f prime of 1/2. So if I plug the 1/2 into here, that's positive out here. That's negative in here. So that's less than 0. So that means it's decreasing. Okay. And then I do the f prime of 2. If I plug the 2 in, that's positive. That's positive in here. So that makes the whole thing positive. So that means it's increasing. Okay. So that tells me that this thing is decreasing from -1 to 1. Okay. From -1 to 1, it's decreasing. And then it's increasing from -infinity to -1 and from 1 to positive infinity. See, it's increasing here and here. All right. So now what we're looking for is we're looking for local max and minimum values. All right. Now, you notice I did this in red. What I would recommend that you do is when you're working these things, whenever you're finding increasing, decreasing, when you're finding your local max mins, whenever you're finding the intervals of concavity, and whenever you're finding inflection points, I would like for you, put a star beside them. Okay. I'm just writing them in different colors, but mark it because you're going to use this to graph. Okay. So we found increasing and decreasing. Now let's look for local maximum and minimum values. All right. So the local maximum and minimum values, well, if you look at this, you notice on this interval here, this graph is increasing. And then when it hits -1, it starts decreasing. So look at that. That tells us that's a local maximum. And then if you see here, it's decreasing, and then here it's increasing. Well, that tells us at 1, we have a local minimum. But here, it's not changing. It's just decreasing the whole time, so there's no local max or min there. All right, so we have a local minimum at 1. Okay. Now, the local minimum, local maximum, those are points on the graph. That's a point coordinate. So we need an x and a y coordinate. Well, we've got the x coordinate. We got that from here. That's 1. Now we need the y coordinate. So do you remember when you have an x coordinate, how do you find the y coordinate? Well, you take the x coordinate, you plug it back into the original function. One of the biggest mistakes students make is they'll take that 1 and plug it back into the derivative. You don't do that. You've got an x coordinate, you're looking for a y coordinate, so you have to plug it back into the original function to get your y coordinate. So that's going to give me f of 1 is equal to 3 times 1 to the 5th minus 5 times 1 cubed. And that's what? That's just -2. Okay. Yep, 3 minus 5, -2. Then we have a local maximum. Well, here's your local maximum at -1. And then we need the y coordinate, so we're going to take the -1, plug it back into the original. And that is going to give us, I believe that's +2. All right. So we found increasing, decreasing. We found local max and min. And now we're looking for concavity. Where's it concave up? Where's it concave down? All right, so let me scroll this up some. And what I'm going to do is right here, I'm going to rewrite the original problem just so we can see it. Okay. And I'm going to leave it about right there for now. All right. So to find concavity, we need the second derivative. Okay. So if you remember earlier, if you remember earlier, here's our function. Well, we took the first derivative, which is this. Okay, there's the first derivative. And so now to find the second derivative, we've got to take the derivative of this. So that is going to be what? 60x cubed minus 30x. All right. And so now you take the second derivative and set it equal to 0. So that's 60x cubed minus 30x equals 0. And so that's going to be, that's going to be 30x times x squared, times 2x minus 1 equals 0. All right, so this is going to give me x equals 0, or, and I'm sorry, that should be 2x squared. Or that's going to give me x squared equals 1/2. So x equals plus or minus square root of 2 over 2. Okay. All right, so that's kind of nasty there, but it'll be okay. All right, so let's plot this on a number line. So we've got negative square root of 2 over 2. We've got square root of 2 over 2 and 0. Okay, so once you find the second derivative, okay, you find the second derivative, you set it equal to 0, solve for x. And those values you get for x, you plot them on the number line. Just look, just like we did up here. And then what that does is that breaks it up, in this case, into 4 regions. So we've got to choose a point from each region. So first, let's see exactly what the square root of 2 over 2 is. That's 0.707. Okay, 0.707. So I can choose x equals -1, x is -1/2, x equals 1/2, and x equal 1. All right, so now I have to evaluate the second derivative at each of these values here. So let's do f of -1. So, well, let's just plug it into the one that's factored. To me, that's just easier to evaluate. Well, so if I plug the -1 in, that's going to be what? That's a negative out here, right? 30 times -1. And then if I plug the -1 into here, that's 2 times 1 is 2 minus 1. That's positive. So I have a negative times a positive. So that's negative. So that means it's concave down. And I'm sorry, that should be f double prime. And then I have f double prime of -1/2. So that's going to be a negative out here. And then if I plug the -1/2 in, that's going to be what? 1/4. And so 2 times 1/4 is 1/2 minus 1. That's negative. So a negative times a negative is positive. And so that means here it's concave upward. And then we've got f double prime of 1/2. So if I plug the 1/2 in, that's positive. That's going to be negative in here. So a positive times a negative is negative. So that's concave down. And then the f of f double prime of 1, that's going to be what? A positive and a positive. So that's going to make it positive. And so that's concave upward. And so that tells me it is concave downward from -infinity to negative square root of 2 over 2 and 0 to square root of 2 over 2. And then it's concave upward from negative square root of 2 over 2 to 0 and square root of 2 over 2 to infinity. All right. Now what we're looking for is inflection points. All right, so the inflection point or inflection points, that's where the graph changes concavity. Okay, so that's what we're looking for, where it changes concavity. Well, you can see it changes concavity at negative square root of 2 over 2, 0, and square root of 2 over 2. Okay, so that gives us inflection points at negative square root of 2 over 2. Let's move this up. 0 and square root of 2 over 2. That's inflection points, because see, it changes from concave down to concave up to concave down, and concave down to concave up. All right, so how do we find the inflection point? Well, it's a point. So we've got the x-coordinate. How do we find the y-coordinate? We've got to plug it back into the original. So we've got f of x is equal to, what was that, 3x to the 5th minus 5x cubed. All right, so I'm going to write this f of negative square root of 2 over 2 is equal to f of 0. Well, that one's easy. If we plug the 0 in, we just get 0. And then we've got f of square root of 2 over 2. So for these, you'll need to punch these into your calculator. So I'll go ahead and do that, and then I'll start the video back up when I get the answers. All right, so this is what I came up with, assuming I punched it in my calculator right. I'm sure if I didn't, I'll hear about it in the comments. But anyway, there's your inflection points. Okay, so you just take this, you plug it in for x here and here, punch it in your calculator, and I believe this is what you should get. All right, so now we found everything. We've got increasing, decreasing, local max, min, concavity, and points of inflection. So now we need all this information in red, and we're going to use that to sketch our graph. So I'm going to get rid of everything else except for the stuff in red, and we'll sketch the graph, and I'll pause while I do that. All right, so now let's sketch the graph. So let's draw our XY axis. Well, let's do it in black. All right, so the first thing I want to do is I want to plot my points. So I can see that I've got 1, -2, -1, 2, and then I've got these points to plot. So let's do this. 1, 2. All right, so let's see, 1, -2, that's an easy one to plot. And then we've got -1, 2, plot that one there. And then we've got 0, 0. Now, square root of 2 over 2 and negative square root of 2 over 2. Remember, square root of 2 over 2 was 0.7 something. So the negative would be negative 0.7. So that's going to be between 1 and 0. So that point's going to be here. Let's see, let's plot this one. So we're going to be here, and then we're going to go up just over 1. And then for this one, we'll go to about right in here, and then just below, -1. Like that. Okay, and if you want to, you can label the points. Okay, all right. So now let's see how good we can draw this. And of course, it's probably not going to look as good because the marks I've made here, they're not evenly spaced. If you want your graphs to look better, get you some graph paper and graph it on that. All right. So let's see what we have. So let's label this -1, -2, 1, 2. All right, so let's see. From negative infinity to -1, this thing's increasing. So right down here, we know it's coming up like this. Okay. So let's see. It's increasing to here, and let's check out the concavity. So it's actually concave down. See this? All the way to this point. So that tells me it's going to look like this, and it's going to turn and come back down. Okay, and it's concave up. But look at this. From, where are we? From here, see, -√2/2. That's these values right here and right here, -√2/2 and √2/2. From here to here, it changes to concave upward. So that means when I'm coming down through here, it's going to kind of do like this. I don't know if you can see, and you know, you might want to see it's doing this. It's coming in like this, and then it's changing to concave upward. So you gotta show that. But then look at this. From 0 to √2/2, see, it's going back to concave downward. But also keep in mind, this thing from -1 to 1, it's also decreasing. So we know it's coming down. See, we're going to have to come down to this point and turn back up, because from 1 to infinity, it's increasing. And so when it gets here, it changes concavity. So that means it's going to go like this. Okay. And then from √2/2 to infinity, which is this point, it changes back to concave upward. So it's going to come back in like this. And I don't know if you can tell the exaggeration I have in there, but this is concave down, and then it changes to concave up here. So I kind of drew it in like this, and then back down to concave down, and then back to concave upward. And then it's just going to come back in through here like this. And there's your graph. So really what it's doing is and I'll draw it, it's doing this, 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 and back up. And that's exaggerated a lot, okay? But that's what it's doing, okay? So hopefully this video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.